In this video, what we're going to do is we're going to consider the alcohol homologous series. So we're going to look at the functional group for the alcohols. We're going to look at the names for the first four members of the alcohol homologous series and have a think about their isomers. We're going to have a look at the chemical reactions of the alcohols, or one chemical reaction in particular. And finally, we're going to consider how ethanol, which is an example of an alcohol, can be manufactured, and we'll compare and contrast two different methods for this manufacture. Okay, so the functional group for the alcohol is the OH group. So any molecule which contains an OH group can belong to the alcohol homologous series. So an example of an alcohol is this one. You can see here there are two carbons, so therefore the name would start with eth. It's an alcohol, and the suffix for the alcohol homologous series is ol, and the hydrocarbon there, the two carbons only have a single bond, so therefore it's saturated, so the name for this one would be ethanol. The formula for ethanol might sometimes be written as C2H6O, but normally it's written as C2H5OH, just to indicate that OH group. And therefore the general formula for the alkane homologous series is CnH2n+1OH. Some examples of alcohols, you can see here on the table, the smallest alcohol is methanol with just one carbon. Ethanol is our second member with two carbons, structural formula CH3CH2OH, and the displayed formula there. The third member is propanol, sometimes called propan-1-ol, because the alcohol group here is attached to the end carbon. So this carbon here would be assigned the number 1, and so it would be propan-1-ol. And then the fourth member of the series with four carbons, so C4H9OH is the formula, structural formula CH3CH2CH2CH2OH, and the displayed formula there showing all of the bonds, including the bond between the oxygen and the hydrogen. Sometimes people miss that bond when they're drawing displayed formula for the alcohols. So isomers, so start with C3H7OH, and we've got here the structure of propan-1-ol. It's not possible to have a branch on this carbon chain, but it is possible to put the OH group on a different carbon. So in this case, the OH group is on the second carbon, and the name for this alcohol would be propan-2-ol, because the OH group is attached to the second carbon. Now, isomers of C4H9OH, there are a few more isomers, so we can have butan-1-ol with the alcohol on the number 1 carbon, butan-2-ol with the alcohol on the second carbon, but we can also rearrange our carbon chain, and we can have 2-methyl propan-1-ol and 2-methyl propan-2-ol. And so those are the possible isomers. In an exam, you wouldn't be asked to name the isomers, but it's possible that you might have to draw some of the isomers. Okay, so let's consider the oxidation reactions of the alcohols. Alcohols do readily undergo combustion reactions, and we can see on this video here two spirit burners, one with ethanol in it and one with butanol in it, and both of those alcohols are burning, they're giving off energy, and therefore alcohols are useful as fuels. If I show you the equations for complete combustion, so our ethanol there would react with oxygen to produce carbon dioxide and water. When balancing this equation, remember that the alcohol has one oxygen in it. So when you are counting the oxygens on the right hand side to work out how much O2 you need, just remember that there is an oxygen there in the ethanol. Butanol, and I've shown here butanol, reacts with considerably more oxygen for complete combustion to produce carbon dioxide and water. This means that butanol, although it gives out more energy per molecule when it burns, it is much more likely to undergo incomplete combustion. And you can see that in this video where the butanol has a much brighter coloured flame, indicating more of the incomplete combustion. Ethanol as a fuel is often used to keep food warm. You might have had a cheese fondue where you've got little burners with ethanol in just to keep the cheese melted and warm. What you may not realise is that petrol now contains 10% ethanol mixed with the hydrocarbons. The designation for that ethanol, you might see that when you go to petrol stations, on the petrol pump it says E10 by the petrol. The E10 represents that you've got 10% ethanol in the mixture, and we'll come back to that idea a little bit later. Now the second reaction, this is another oxidation reaction that you need to know, and this happens to alcohol to ethanol, particularly if it's left and it comes into contact with air, and microbes in the ethanol can cause it to oxidize to ethanoic acid. And here's the equation for this reaction. So we've got our ethanol just reacting with oxygen from the air. It's a slow reaction to produce ethanoic acid, which is a carboxylic acid. We'll study that as our next functional group. So ethanoic acid has the formula CH3COOH and also produces some water. Now this happens naturally to the ethanol in alcoholic drinks. So if you've got a bottle of wine, for instance, and you leave the lid off that bottle, over some time the alcohol, the ethanol in that drink will very slowly oxidize to produce ethanoic acid, and vinegar is a solution containing ethanoic acid, and so that's the equation there for that reaction, and it explains why alcoholic drinks, if you leave them open to the air, will very slowly become sour as the ethanol turns basically into vinegar. The third reaction is another oxidation reaction of ethanol to ethanoic acid, but this time it uses an oxidizing agent called potassium dichromate mixed with sulfuric acid. And watch a short video clip here to explain that reaction. The flask contains a mixture of acidified potassium dichromate, and we add some ethanol into that flask. As the ethanol hits the potassium dichromate, the reaction starts to happen. There's a colour change. The potassium dichromate changes from orange to green. The reaction gives out a lot of heat and causes the mixture to boil. Eventually the whole of the mixture turns green as the ethanol oxidizes to ethanoic acid. And an equation for that reaction, so we have our ethanol here producing ethanoic acid plus water. This time we've got our oxidizing agent, our potassium dichromate, is represented just as O rather than as its actual chemical formula. This reaction requires the use of this chemical oxidizing agent, the potassium dichromate. It's a much faster reaction than the microbial oxidation, and note that colour change there in the potassium dichromate of going from orange to green during the reaction. Sometimes you do get asked about that in the exams. And now we're going to consider the manufacture of ethanol. So ethanol, just one of the alcohols, and we're going to consider two different methods here to make ethanol. We'll consider fermentation and hydration of ethene. So the first reaction then is fermentation. Watch a brief video clip to explain fermentation. To make ethanol by fermenting sugar solution, first of all we need to make a solution of sugar by dissolving the sugar in warm water. And then we add yeast, which contains an enzyme that does the fermentation. The mixture can then be placed in a water bath at about 30 degrees C to keep it warm enough for the yeast to work. Calcium hydroxide or lime water can be used to test for the presence of carbon dioxide. During the reaction, the mixture bubbles as the yeast reacts with the sugar solution to produce carbon dioxide and ethanol. As the carbon dioxide bubbles through the lime water starts to go cloudy as the carbon dioxide reacts with the lime water to produce calcium carbonate, which doesn't dissolve, and you can see the solution gradually getting more and more opaque. And then finally, to obtain the ethanol from the sugar and yeast solution, you need to do fractional distillation to separate the ethanol, which has a lower boiling point than the water, and to get that pure ethanol. So equation for this reaction, we've got our glucose here from sugar, and the glucose reacts with yeast at a temperature of 30 degrees C. It's important that the reaction is anaerobic, so it's done in the absence of atmospheric oxygen, and under those conditions we produce ethanol plus carbon dioxide. If the reaction is done in a non-anaerobic condition, so if there is air in there, we're unlikely to produce the ethanol. We're more likely just to make carbon dioxide and water in that case. One of the benefits of this reaction is that sugar is readily available. You can grow plants like sugarcane, which produces sugar. So therefore this is a very low technology reaction, low technology process. Yeast and low temperatures also easy to come by, easy to produce. And so ethanol produced by fermentation is often known as bioethanol, and it's this ethanol which is added to petrol in order to increase the amount of renewable energy contained within petrol. And some countries such as Brazil, which have access to a lot of sugar containing plants, tend to produce quite a lot of bioethanol, and therefore their cars generally run on a much higher proportion of bioethanol. The ethanol that's produced, as mentioned in the video, is impure, and so in order to obtain pure ethanol from that, you need to undergo fractional distillation to separate the ethanol from the mixture. Sometimes, of course, if you are fermenting sugar to produce an alcoholic drink, you don't want to produce too much ethanol. You don't want to have too high a concentration of ethanol in the mixture. The second method that we can use to produce ethanol is by doing a hydration reaction with ethene. So if we take ethene, C2H4, and react it with steam, we can produce ethanol as a product. And looking at the equation for this reaction, you can see here that ethene, steam, and ethanol, it's an addition reaction, as you'd expect for the alkenes, because we only make one product. Now, the benefit of this reaction is it's very fast, unlike the fermentation, and the ethanol that's produced is pure. And so if we were producing ethanol just to use as a fuel, this is a very good way of producing it. We wouldn't make ethanol this way in the manufacture of alcoholic drinks. The conditions for this reaction, we do need a high temperature of about 300 degrees C and a catalyst of phosphoric acid, as well as a high pressure of about 60 to 70 times atmospheric pressure. So the conditions required for hydration of ethene are much more severe than the conditions required for fermentation. So what I'd like to do now is just to have a look at a comparison of the two different methods of the manufacture of ethanol. So fermentation of glucose, the only thing we need for this is glucose, which we can obtain from plants. For the hydration of ethene, we need to use ethene, which we normally obtain by cracking hydrocarbons. So this is a non-renewable resource. The conditions for fermentation, low temperature, 30 degrees C, yeast for the enzymes, anaerobic, it's very easy to do. The conditions for the hydration of ethene, on the other hand, are much more severe, so much higher temperature, phosphoric acid, and that pressure as well of 60 to 70 atmospheres. The fermentation rate of reaction is very slow. It takes several days to produce the ethanol, whereas hydrating ethene happens very, very quickly. And then in terms of the purity of the product, the ethanol produced by fermentation is a solution, and so if we wanted that ethanol, we must separate it from the mixture by fractional distillation, which is time consuming and requires some more energy. However, by hydrating ethene, we do produce pure ethanol. So you can see from this comparison that there's quite a lot of advantages and disadvantages to both methods. And sometimes in an exam, you might be asked to do a comparison of the two different methods. Okay, so in this video we have studied the alcohols, so hopefully now you've got an understanding of the functional group for the alcohol homologous series. You know the names of the first four members of the homologous series. We've studied their reactions, specifically their oxidation reactions, three different reactions: combustion, microbial oxidation, and oxidation with an oxidizing agent. And finally, we've considered the manufacture of ethanol by fermentation and by the hydration of ethene using steam and high temperature and catalyst and high pressure as well.